So this is the code, and I have created three buttons to toggle the three LEDs, the red one, green one, and the blue one. And here I have added the Firebase credentials. So when I will touch the red button for the LED, it will blink the LED, and when I will touch the green button, it will turn on the green LED. As you can see, and when I will touch the blue LED, it will turn on the blue LED. So the purpose of this task was to remotely call functions from the web to run on the Arduino device. So my system shows that how the LEDs representing red, green and blue can be instantly switched from the browser, which would translate to controlling actual lights at a junction. So in the Arduino code, I use the two libraries Wi-Fi Nina and Arduino HTTP client. I use these to give the Arduino a secure HTTP connection to the Firebase. So what this actually does is that it helps the Arduino fetch the new LED states every 2 seconds. So I've implemented modular programming approach in the code. So I've split my code into small functions so that each function has a single responsibility. This makes it easier to debug and reuse some parts of the code. Now talking a bit about web page buttons. The HTML page directly writes LED state to the Firebase. This means that I don't need to run a separate server. Now I will explain some of the important functions that I've used in the code. So I've used a connect Wi-Fi function. It only handles the job of connecting to the Wi-Fi. So the next important function is the get LED states. This function calls the Firebase and returns the raw JSON. Next one is the update LEDs function. This function will help to add more LEDs in the future. Next one is the toggle LED function. This abstracts the actual digital write calls. The Arduino only needs to know the color and the state, and this function will take care of writing high or low to the correct pin. Some more important functions are the window.toggle LED function. When we press a button on the page, this function flips the LED state in the local object and writes it back to the Firebase. So there was a question in the task sheet that how would you improve this task using other technologies or libraries. So I've identified several ways to make it more faster, safer and more scalable. Right now my Arduino fetches the LED state every 2 seconds, but in real traffic light we will need instant updates. So I would switch to a protocol like the MQTT, where the Arduino subscribes to a function and receives the changes immediately. Second point is that the Arduino page that I built is basic. I'd upgrade it to a responsive web app that shows the live status of every light. Also, it would include manual control and time settings. This would make it much easier for the operators to manage multiple junctions.